If you think this is a boring question, then you are completely wrong. Number one, let's have a look at the graph of this gorgeous parametric function and see what that tangent actually looks like. Well, here's the graph, and that's exciting enough in its own right, to be honest. But now we're going to put a tangent on it at the point where t is pi by 6. So let's work out in terms of the Cartesian coordinates, if t is pi by 6, what coordinate we're looking at. So x is going to equal cos of 3 lots of pi by 6, and y is going to equal sine of 4 lots of pi by 6. So this is cos of pi by 2, which is 0. Oh, exciting. X is 0, so we are on the y-axis. And we're doing sine of 2 pi by 3, which is root 3 over 2. Okay, so we're looking for the point where x is 0 and y is root 3 over 2, so we are here. Now, I don't actually know whether we're on our way down or on our way up at the moment. At this value, t is pi by 6. For all I know, t is pi by 6 here when we're on the way up, or maybe t is pi by 6 here when we're on the way down. But it's definitely that point there that we're going to draw the tangent at. And when I find whether the gradient's negative or positive, then I'll know which of those tangents that I've got. So let's do that now. But how am I going to find dy by dx? That's the big problem. Only it's not a problem, because we've got the chain rule. The chain rule is specifically designed for helping us to differentiate things when things are inside things. So t is inside x, t is inside y, and the chain rule tells us that dy by dx is equivalent to dy by dt, dt by dx. And actually, it also tells us that dt by dx is the reciprocal of dx by dt. So I could write this as dy by dt times 1 over dx by dt, or, more nicely, dy by dx is dy by dt over dx by dt. It's really easy to remember. If you want the derivative, you do dy by dx, the derivative of y with respect to t, over the derivative of x with respect to t. Couldn't be simpler. Let's have a go. Dy by dx equals the derivative of y. Well, y is sine 4t, so the derivative with respect to t is cos 4t, but then chain rule multiplied by the derivative of the baby, which is the 4t, times 4, and on the bottom, dx, dy by dx, on the bottom dx by dt, derivative of cos is minus sine, and then multiplied by the derivative of the 3t, which is 3. Okay, that's our dy by dx. We know that we're at the point t is pi by 6, so we need to put that into the top and the bottom, giving us 4 cos 4 pi by 6 over minus 3 sine 3 pi by 6, which is 4 times minus half over minus 3 times 1, giving a gradient of 2/3. Positive gradient. So I must have been at this point on my way up when I got to t is pi by 6. So I'm getting this line here with the positive gradient. So let's make the actual equation of the tangent now. This is all very easy now, it's just C1. X minus a is y minus b. This is our tangent line here. We know the point on the line is the point x was 0, and b is the y coordinate, which was root 3 over 2. And we've worked out what the gradient is, it's 2/3, giving us a tangent line. 2/3 x is y minus root 3 over 2. Fun. And not only fun, also easy, because the only thing you need to know is that dy by dx is dy by dt over dx by dt, which you can remember as dy by dx is dy by dx. Okay, now we know what we're doing. Let's try this one. So we want the equation of the tangent at the point 0, 4. X minus a is y minus b. How much of this do we know? We know that a is 0, we know that b is 4, all we need is m, and we know that m is dy by dx. dy by dx is the derivative of y with respect to t, which is 2t, divided by the derivative of x with respect to t, which is 5t to the 4 minus 12t squared. I can simplify that a little bit by dividing through by t. 5t cubed minus 12t. Okay, now what's t? I need to know what t is. At t equals what? Don't know. Okay, gonna have to work that out. Well, x is 0 and x is t to the 5 minus 4t cubed. And y is 4 and y is t squared. So t squared is 4, so t is plus or minus 2. What do I get from this equation? I can pull out t cubed, giving me t squared minus 4 is 0. So t is 0, well that's no good. That t is 0 doesn't match up with one of these. So the point where t is 0 would give me x is 0, but it wouldn't give me y is 4. The other bit of the equation gives me t is plus or minus 2. So actually I've got two t values I could be talking about here. So which one do I want? Well, let's do both and see what happens. At t is 2, we would get a gradient dy by dx is 2 over 5 lots of 2 cubed minus 12 lots of 2, which is 1 over 8. And at t is minus 2, we get dy by dx is 2 over 5 lots of minus 2 cubed minus 12 lots of minus 2, which is giving us minus 1 over 8. So there's actually two tangents. We've got a tangent at t is 2, which would be given by 1/8 x minus 0 is y minus 4. And we've also got a tangent at t is minus 2, given by minus 1/8 x minus 0 is y minus 4. Let's have a look at the graph, because it's always more obvious what's going on when we look at the graph. Oh yes, that makes sense. Look, we've got at the point here, the point 0, 4, we've got actually the graph is coming down like this, and there's the point 0, 4, and then that's where t is 2, and that gave us that positive, oh sorry, no, that's t is minus 2, isn't it? T is minus 2 is what gave us the negative gradient. So here's the point where t is minus 2, then it carries on and carries on round. Here's t is 2 now, and that's given us that positive one there, and then going round again. There we go. Okay, last one. So we're trying to find not equation of a tangent this time, but the coordinates of the points on the parametric curve where the tangent is horizontal. Now, horizontal tangent, that tells us straight away we're looking for a tangent like this, which means that dy by dx equals 0. So that's what we're going to try and solve. So let's have a go. Dy by dx is equal to the derivative of y with respect to t over the derivative of x with respect to t. And we want that to equal 0. 0 equals 6t over 3t squared minus 3. Multiplying both sides by 3t squared minus 3, and remembering that 0 times anything is in fact 0, we get t is 0. If t is 0, we can split that into what's our x coordinate and what's our y coordinate. Our x coordinate will be 0 cubed minus 3 lots of 0, which is 0, and our y coordinate will be 3 lots of 0 squared minus 9, which is minus 9. So the point, the only single point on the parametric curve where the tangent is horizontal is, the answer to part A, is 0, minus 9. Okay, let's have a look at part B. Now in part B, we're asked to find where the tangent is vertical. So the curve must be coming round like this and the tangent's vertical. Now you can kind of think of that as being dy by dx is infinity. It's an infinite gradient. But we know that dy by dx is the reciprocal of dx by dy. So if dy by dx is infinite, then dx by dy must be 0. It's not that the reciprocal of infinity is 0 and the reciprocal of 0 is infinity, because you can't do 1 over 0, but we say that these are equivalent. If dy by dx is infinity, dx by dy is 0, just like if cot x equals 0, tan x has an asymptote, and if tan x is 0, cot x has an asymptote. Same idea. Okay, so let's try to solve dx by dy is 0. Now dx by dy is just the reciprocal of dy by dx, so it will be 3t squared minus 3 over 6t. So if we solve that is 0, multiplying both sides by 6t, remembering that anything times 0 is 0, we get 3t squared minus 3. And if we solve that equation, we get t squared is 1, so t is plus or minus 1. Okay, let's feed that in. If t is 1, then x is 1 cubed minus 3 lots of 1, which is minus 2, and y equals 3 lots of minus 1. Oh, this is just 1, isn't it? 3 lots of 1 squared minus 9, which is minus 6. If t is minus 1, then we're going to get x equals minus 1 cubed minus 3 lots of minus 1, which is minus 1 plus 3, which is 2. And y is equal to 3 lots of minus 1 squared minus 9, which is 3 minus 9, which is again minus 6. So the answer to part B, the coordinates of the point where the tangent is vertical, so that's dy by dx is infinity, so dx by dy is 0, are given by 2 minus 6 and 2 minus 6. Let's have a look at the graph of this lovely function and see if that makes sense. Yep, we were right. 0 minus 9. Here it is down here. T is negative, t is less negative, less negative, less negative, less negative, and there is 0. And at that point there, the tangent to the parametric curve is horizontal. Then in t it's increasing and increasing. Here's our t is 1 that we got over here. There's the minus 2, minus 6 point where the tangent is vertical, and then it goes off again like this. And here's our t is minus 1, the point 2, minus 6 where the tangent is also vertical. So in summary, if you want the gradient of a parametric curve, you use the chain rule. Dy by dx is dy by d theta, dx by d theta. You can just think of it as dy, derivative of y, by dx, derivative of x. And then to get the gradient of the tangent at a specific point, you feed in your value of theta at that point. Easy peasy.